Well, hello everyone. Good morning or afternoon or evening, depending on where you are in the world, and welcome to today's webinar, Sustainable Broadband, Transforming Fixed Broadband Networks with Energy Efficient Solutions. And it's brought to you today by the World Broadband Association and broadcast by Informa. I'm Martin Kriener. I'm the Director General of the World Broadband Association, and I'll be moderating today's webinar. We've just a few announcements to make before we begin. First of all, the webinar is designed to be interactive, so you'll see a dock of widgets at the bottom of your screen that will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session, which will take place at the end of the presentation. The slides will advance automatically. You don't need to do anything. You may also download a copy of the slides via the resources widget. Towards the end of the webinar, we're going to ask you to complete a survey, which will be found in the right-hand side of your screen. Please do take a minute to fill this out before leaving us today, as your feedback will certainly help and provide us with valuable information on how we can improve things in the future. Lastly, if you run into any technical issues, there's a help widget found in the bottom of your screen, or else just type whatever your question is into the Q&A area and we'll be able to offer some sort of assistance on that. Now, on to our presentation. As I say, the topic today is sustainable broadband, transforming fixed broadband networks with energy efficient solutions. And joining me today in this is Philip de Grieve, who's the Product Marketing Director for Fixed Networks at Nokia. We have Alsbeta Fellenbaum, who's a principal analyst with Omdia. We have James Zhao, who's a senior expert in optical standards in Huawei. And we have Mohammed Benzian, who's vice chairman of Algerie Telecom. And with no further ado, let's launch straight into the presentation. And first up, Alsbeta, you'll be sharing some thoughts on this. So I'll hand over to you, Alsbeta.
Great, thank you, Martin. And thank you everyone for joining. In this part of our webinar, we will go over some of the key messages and key points that you will be able to find in the Energy Efficiency Toolkit that is available for you to download in the resource section of this webinar. And we will try to have a bit more of an interactive discussion. So I will be calling on our panelists to provide kind of their views and experiences throughout this presentation. So hopefully you'll appreciate this format and everything will go smoothly. But just to start us off, so energy efficiency is a core element of environmental sustainability policies and that have been introduced in recent years, and it's essential to the achievement of net zero goals. For the telecom and broadband industry specifically, reducing energy consumption has become an important aspect in carbon footprint reduction, as well as a key performance indicator that is used to showcase successful network operations, and it's also a useful tool for vendor selection. So for this reason, the WBBA Sustainability Working Group made energy efficiency the focus of its activity earlier this year. And this led to the production of the Energy Efficiency Toolkit that has been already published on the WBBA website. And as I said, you can download it as part of this webinar materials. The toolkit itself aims to deepen the understanding of the available technologies and solutions that can help in improving energy efficiency, especially with the focus on fixed broadband networks. And our working group identified 5 key areas where the broadband industry can and should focus its effort to achieve better energy efficiency. So these are migration of legacy, primarily copper networks to full fiber. Then it's network innovation using simplified network architecture and artificial intelligence solutions. Third is creation of energy efficiency facilities. Fourth is the focus on energy efficiency of customer premise equipment. And the last one is adoption of unified industry-wide energy efficiency measurement indicators and methodologies. So moving to the first key area that we've focused on. So numerous studies, which are highlighted in the toolkit, have been published in recent years examining the power consumption of various broadband access network technologies. And they have all concluded that the benefits of fiber networks are undeniable. Whether it's measured as a power consumption in megawatt hours per year, kilowatt hour per line, or power watts consumed per subscriber, which are highlighted in the chart on the right side. Fiber to the home and specifically GPON networks come out as the most energy efficient. Successful migration of legacy technologies to fiber can also considerably reduce service space and enable the decommissioning of entire buildings, which in and of itself contributes to energy optimization. Now, I would like to ask Philippe. And so Nokia has conducted one of the studies that are highlighted in the toolkit, and the chart is actually from your study. So could you maybe talk a bit about the improvements that GPON and XGS-PON solution networks or solutions bring for improving energy efficiency?
Yeah, absolutely, Alberta. So I think overall fixed access technologies are well positioned to keep emissions under control, even despite ever-growing traffic demands. And simply the fact, indeed, if you can move from a copper-based network to a fiber-based network is giving operators a tremendous saving. Typically, in theory, these fiber networks are 10 times as efficient. Fiber is so power efficient. You can see it here on the slide compared to a G.fast copper-based technology. That's 1.6 times more power consuming. An operator could offload through reverse powering a part of that technology from the network side to the home side, but that doesn't change the total cost. PONs are so efficient when it comes to broadband. You got now 25 gigabit PON, which is the most power efficient technology on the market today. And with each next generation, we will expect higher efficiency gains to be achieved. On the image, you can see indeed GPON as being the most power efficient one when you look at it per line or per user. Now, XGS-PON is actually more power efficient when you look at it per bit, because it's having 5 times the speed for only 2 times more power. So typically when you would, let's say, double the amount of users from 64 to 128 on a PON, you could actually even reduce the footprint. And last but not least, when you also look to fixed wireless access, being fiber so efficient, it's like a laser focusing all the energy inside of an optical cable. When you have to radiate, of course, the same type of energy through the air, you can expect indeed to be less efficient. In this case, about 8 times less efficient. But with high gain antennas, massive MIMO, and even with outdoor receivers, you can do a lot to also improve the efficiency and throughput of fixed wireless access.
Great, thank you. And we know that many operators worldwide have already begun decommissioning their copper networks, and we're lucky to have a representative of a service provider operator on our panel. So, Mohammed, from the perspective of a network operator, what is Algerie Telecom's strategy for migration to fiber? Could you maybe talk a little bit about that, kind of where you are on this journey and what your key priorities and concerns are?
Well, thank you, Asbeta, for the question. I think our approach to let's say the PSTN sunset, I think this has been started few years earlier, and of course we are in very great momentum towards migrating towards all fiber-based access infrastructure. I think the approach can be summarized through a couple of points. The first one, I think we have adopted the phased migration approach, in which we targeted the vendors, and of course we deal with multiple vendors in deploying access network. And of course, this strategy of diversifying the vendors is very key for us in terms of, looking to diverse approaches and quality of service among the vendors. And of course, the targeting some sort of, country regions that, we targeted that first deployment in terms of migrating towards fiber, and then go to nationwide deployment, because, sometimes the territory is vast. So we need to have a phased approach in that sense, right? So this simultaneously, we are leveraging existing VDSL infrastructure. So as long as we are moving subscribers to full FTTH, there are subscribers who are looking for VDSL, and of course VDSL is not going to last for a while, but we are just maintaining our first phase these two approaches while moving entirely towards whole and full fiber-based FTTH network, right? And of course, the engagement with the vendors is very key, and including the national stakeholders, whether they are the regulators, the municipalities in terms of right-of-ways, and cooperation with the grid providers and the power grid providers in terms of powering new sites and etc. And of course, all these efforts are coupled with upgrading the transport network, right? So we, in order for us to move to gigabit speeds in the access, and next in 10 gigabit speeds with XG-PON, so you need to have robust transport infrastructure where you need to modernize and upgrade your IP-based infrastructure. You need to upgrade your OTN, and the next slide you see the cross connects. We have more let's say towards terabyte switching capacities in the aggregation and core, and so all of these efforts need to go hand in hand. And finally, a continuous improvement of the network and monitoring when it comes to QoS and etc. So and the SLAs with the suppliers and the customers. Yeah, thank you.
Great. Thank you so much for the comprehensive overview, which leads us to the next key area, and Mohammed, you've already mentioned it. So the second kind of area that we focus on is the network evolution toward higher efficiency. And also we mentioned in our toolkit the use of AI solutions, which can help optimize power consumption by monitoring traffic changes and managing transmission route paths, traffic volumes, and allocation policies. But one of the solutions that we've looked at specifically in terms of simplified optical network architecture, which can effectively and efficiently reduce overall energy consumption because it has the least pass-through traffic and the fewest redundant nodes and equipment. So one of these solutions is optical cross-connect, which offers a more flexible solution with an all-optical cross-connection roaming mode. And James, I know you have developed this solution, and it would be great if maybe you could give us a bit more detail on how optical cross-connect works and how it leads to improved energy efficiency.
Yeah, thank you, Elzbieta. Yeah, actually, in this page, the figure shows the principle of how optical cross-connect help to improve the energy efficiency. So in the left-hand side, you can see that the prior art is so the OTN only to the core or metro. So the typical network used normally you have a structure or architecture of a ring. So the whole network is a ring, connect to a ring, and connect to a ring. So the traffic will go through the network hop by hop, and for each hop you need convert from optical to electronic and electronic to optical. So which consume a lot of power and also cause resulting delays. So optical connect enables the colorless, directionless, and the contentionless connection, optical layer connection directly from one hop to another one. And so based on this technology, you can, from some of the traffics, I'm not saying all of the traffics, some of the traffics you can directly go from the server to the end user or the end edge point, or from the edge point to the core, which with a shortcut to avoid, you don't need to go through each hop to avoid the optical to electronic, electronic to optical conversion, and this will help to reduce the energy consumption and improve the energy efficiency. Thank you, Peter.
Yeah, great. Thank you so much for that explanation. And moving swiftly to our third area, which looks at improving energy efficiency of network facilities. So the power consumption of a network site has two components: power consumption of the main equipment and power consumption of the auxiliary devices, such as air conditioner and power supply in the equipment room. And the site facilities, as air conditioning, power supply, often consumes as much energy as the main equipment on the site. So investing in energy efficient buildings and network facilities can really make a difference. And improvements in efficiency of cooling and power supply is really essential part of this endeavor. We highlighted in our toolkit some advanced solutions such as smart ventilation, heat exchangers, heat piping, liquid cooling, thermo tanks. They have all been considered to ease the strain on air conditioning and reduce energy consumption. Now, I know, Mohammed, that you have looked at some of the evolution of energy efficiency in telecom rooms in general. So maybe could you give us a bit more insight into the innovation that has taken place and how it leads to improved energy efficiency? I know there is a lot on this slide. It will be available to you after the webinar, but maybe Mohammed can give us a quick rundown of the key points that have been highlighted here.
Yes, thank you, Elzbieta. So the key point here on this slide are, according to the ITU-T standard L1382, is that the telecom rooms are evolving because there are new trends in the telecom room. So you can see on the right-hand side, which is the integrated access telecom room, there are new, equipment and appliances that are common to these areas of telecom rooms, like the WDM is much more going to the access. There are other BBUs when it comes to the 4G or the 5G, and even IT devices are being brought to the access telecom rooms. And then edge servers, storage servers, when it comes, for example, to Cloud RAN and other cloud access applications. So these developments, of course, increase the power consumption of the access telecom rooms. And you can see in the middle, again, the aggregation telecom room, of course, that, see the introduction of WDM, more robust and more increased capacities in WDM devices. We see also metro routing being integrated into the aggregation, including the edge devices, the servers and the storage devices being introduced into the edge. So like the mobile edge compute, for example. And these also put strain into the power consumption. And finally, on the left-hand side, trends in the core, where you can see more powerful backbone routers when it comes to IP or DWDM transmission equipment with terabit capacities and more racks servers being introduced. CDNs, for example, content delivery network servers, are being brought to the core for massive deployment. So of course, they increase, power consumption and devices. We put strains on the operators' perspective in order to tackle these increase of power consumption at different layers of the network. So this is the key point here in this diagram.
Okay, great, thank you. Thank you so much. Now our fourth area of focus was looking more kind of at improving energy efficiency in consumer homes. So that can actually lead to improvement and have a positive impact on service providers or operators' Scope 3 emissions. And that is the improvement of energy efficiency of customer premise equipment. So, routers, modems that are being installed in consumers' homes and then have positive impact on power consumption within consumer home, which is an important part of Scope 3 impact for service providers. So you can see on the chart on the left-hand side that CPs can be responsible for over 3/4 of the total power consumption of fixed broadband network in the home, and that depends on the access technology. And they then play a big role in terms of how much energy is consumed, and kind of attention needs to be paid to the home network and the home devices or the premise equipment devices themselves. Now, on the right-hand side, we see a comparison of the two latest Wi-Fi standards, the 6 and 6E compared to the newest standard Wi-Fi 7. And Philippe, I know that you work on that or on Wi-Fi 7. Nokia has CP enabled for Wi-Fi 7. So can you talk a little bit more about how significantly Wi-Fi 7 improves energy efficiency and what benefits the new standard brings?
Yeah, indeed. While still Wi-Fi 6, I believe, is now the one that's shipping the most. And already, I think even in Wi-Fi 6, there have been already a lot of improvements to make it a very efficient wireless technology. There are still some improvements that are being made by moving to Wi-Fi 7. And indeed, as you can see, in general, the Wi-Fi part is taking a significant portion of the power consumption. There's also the overall CPE or ONT footprint. Typically, we've seen already over the past 10 years that the overall power consumption of these type of devices has been reduced by 40% or maybe even more. And I think with the evolution to Wi-Fi, to Wi-Fi 7, you'll see a lot more efficiency gains when it comes to the data rates and the throughput and how the bits are transferred. So, for example, Wi-Fi 7 is using broader channels, 320 megahertz. Also, the coding has increased. It's a 4K QAM coding with more efficient or less transmission overhead. Also, the spectral efficiency is higher, meaning that when you have those channels and there is some interference, you can still use a part of the channel to still be able to transmit, or you also don't need to use the entire channel. You can share it between different users. So there are really a number of means in Wi-Fi 7 to make sure that data transfers can be completed as fast as possible, and that these devices can return to the low power state, which is of course very important when it comes to energy efficiency, returning as fast as possible to low power states to keep energy levels as low as possible.
Great, thank you so much. And our last area of focus that we discuss in the toolkit centers around the importance of unified energy consumption measurement indicators, because that is one of the key challenges for the telecom industry, is how to measure energy efficiency efficiently. And there currently aren't any unified standards. So right now, network operators and service providers, they are developing their own studies on end-to-end energy consumption, and energy efficiency needs to be looked at as a whole. We do see kind of differences also in between regions. We see that Europe has, we know that Europe has the EU Code of Conduct, which is mandatory for European operators, while in the US, for example, it's the approach is more voluntary. So there is a voluntary agreement for the ongoing improvement of energy efficiency of small network equipment. But again, these are region-based, and as we said, some are voluntary, some are more mandatory. But we do, in terms of the industry as a whole, there needs to be a way to measure in a unified way. There are also some standards that are being implemented at the moment. There's energy efficiency rating developed by the ITU. There's equipment type specific ER definitions. There's also ETSI standards and ATIS standards. But we'd still like kind of a unified examination of energy efficiency for the whole network, not just individual equipments or the transmitting information for bits. It has to, so our conclusion in the toolkit is that there should be a whole network view and measurement developed that could be adopted throughout the industry, which would then lead to better ways of measuring, comparing, and developing a kind of a unified KPI that would help the industry move forward, and then develop solutions that would be tailored to these KPIs. And I think that brings us to the end of the presentation section, and I will hand back over to Martin, who will take us through some panel discussion. So Martin,
that's
over
great,
to you.
Elspeth, and that gives us a really good overview of the paper, and it's a hugely important paper as well, I think, in terms of the necessity for everybody in the industry to be laser focused on reducing the amount of energy that we use in our broadband networks. And I think that obviously it's got a moral imperative, but it's also got a very strong financial imperative, because it's a non-trivial cost line for every operator out there. Maybe I could bring us back to the start there, and Philip, maybe a first question to you. You're talking about migration of copper to fiber, and how there's about a 10x power efficiency as you migrate from copper to fiber, and how 25G PON is super efficient, the most efficient solution currently out there. Can you talk a bit more about that and how this has been received by Nokia customers, and the challenges in helping customers make this type of migration?
Yeah. I think if you're a greenfield operator and you're deploying a new network, it's a no-brainer to go for fiber. But obviously, if you have an existing customer base, making that transition from copper to fiber is less obvious. And I think the challenge is, do I move slow? Do I move fast? And I'd say that in most cases, and again, it depends a bit, of course, on fiber availability and things like that, but going fast is usually the better approach. because you're able to bank on the improvements that you can achieve. And also, if you're first with fiber, there's nobody else that comes first. So maybe a last thing that I want to add is in this challenge, it's probably also very beneficial to go for large areas that you can convert. Don't try to convert one by one. Typically, the coordination is very expensive and very time consuming to roll out fiber. So you typically would do that in large areas or high value areas. And also you will be able only to make the savings when you're able to switch off devices in your central office. So it's until the last customer in a street or a neighborhood or an area that is disconnected, you will be able to get those savings and see it either on your bill or in your emissions that you're reporting as a company.
Yeah, and I mean that last point you make is so important, because as during the transition process, you're essentially carrying multiple cost lines on your balance sheet, and then when you can eventually switch off your copper network, that's when the real benefits kick in. So the speed of doing it is so important. And Mohammed, I mean, you gave some insights into that. I mean, what you described sounded like a very pragmatic approach in doing this, a phased approach, a multi-vendor approach. You're also continuing to be able to offer certain customers DSL offerings as appropriate. In terms of how best to do this, is there any additional ideas you have about advising operators in terms of how to approach this, or any additional lessons that you have learned that you would do differently if you were starting today as opposed to a couple of years back?
Yes, thank you, Martin. I think the most important things that I have mentioned is the phased approach, and of course, this is the most important and key lessons learned to us in terms of smoothly introducing new technology and migrating existing one, while collaborating internally with other internal stakeholders within the company, because I think it's really a collaborative work among the access networks team, the core team, the transport, and even the platform, etc. So it's really an end-to-end collaborative approach. And of course, what's the most important, another point is really the commitment from the company towards really putting investment, right? And of course, one of the things that we have been putting in place in WBBA is the investment guidebook. And I think having the commitment by the management in terms of putting the right investment to the right technology is very, very key, right? In order to allow smooth operations, procurements is going into the right direction without delays, and etc. And so the stakeholders and the customers and the vendors are also another key player. So it's more approach rather than an ultimate one key element. It's really a subset, and of course the training of the engineers that are on the ground and those who are developing and collaborating with the vendors in the engineering aspect and the design aspect of the solutions and the architecture of the network is very, very key. And I think so. As I said, Martin, it's really a multifaceted key aspect rather than one. I may maybe introduce some others, but these are the most important ones.
Yeah, you just mentioned a very important one there, as well as training and the upskilling of your existing resource in order to do that. Did you find that to be an easy process, a very difficult process? Could you say a little bit about that side of the challenge?
It's not really difficult. I think the training, because you have engineers already have technical background, so they are flexible to move to a newer technology. And I think one of the, maybe I suggest, the difficult and the step that need to be carefully undertaken is fiber-based infrastructure is heavy project, and so you need to collaborate, for example, with third parties in which they should fulfill certain requirement and SLAs with the company, right? So you need constantly track the performance of these suppliers and third parties who develop, for example, the passive infrastructure, right? So you need to deploy passive infrastructure in a timely manner. And so this aspect introduces delay in terms of delivering the products and services. So, and this is a delay for introducing fiber-based infrastructure is one of the challenges that I may say in terms of migrating from copper to fiber. I hope that I have answered your question, Martin.
Did we lose Martin?
So. I think we may have lost Martin here a little bit. So let me. Oh, there he is. I don't have to take over. Good. Okay, go back.
So I dropped out there. Apologies on that one. But I think I got most of that from what you're saying, Mohammed. Maybe we could move on to James for a second question here. In terms of, there was another very important discussion around network simplification, and Mohammed had mentioned, that the copper to fiber approach is a full network approach, and we need to think about it end to end. You can't just think about it in a simplistic fashion. But in terms of network simplification, James, you talked about the whole approach with optical cross connects. And can you talk a bit more about that approach, but also about the benefits of this simplification that you're seeing across the operators that Huawei works with? James?
Yes, thank you, Martin. Yeah, as I just explained in the slides that by introducing the optical cross connect, we can implement a full optical connectivity, and to avoid a lot of optical to electronic and electronic to optical conversion, and so then we remove majority of the electric hops of the network. So logically, you can see the network will be quite simpler for this kind of traffics. So if we move even further, then we can consider, in some of these network segment, for example, core network or metro aggregation network. So you can build a pure optical network which no need for OEO conversion. So this dramatically simplify the network. This can reduce the hierarchicals from the traditional network to maybe only one. So this enables what's called one hop to the network from the end user to the cloud. So this dramatically reduce the latency and also reduce the energy consumption. Why we mentioned the optical cross connect, because this is the key enabler of to support this evolution. So in the past we use ROADM. So ROADM, you need a lot of cross connect fibers, fiber cable to connect the different part of a ROADM. So the optical cross connect, what are also abbreviated as OXC, can integrate all of this cross-connected fiber cable into a backplane, which is called optical backplane, and then all of these devices can be integrated to from in the past maybe you have a NAND racks and which can concentrate it to only one. So this dramatically improve the room and also reduce the energy consumption of the ROADM itself. So this is from the core and the aggregation network architecture. From the metro access, it's also a typically ring network. So in the past, for each ring, they have a dedicated optic edge. So you cannot share resources, for example, wavelength resources among different rings. So this results in, if you need a dedicated wavelength resources, even though no matter you use it or no, you don't need to use it. So this causes also, capex and also energy consumption. So based on the optical cross connect, we can enable the wavelength sharing among each rings connect to these two optical edge. So this we call a wavelength pool. So then each wavelength can be shared among all rings which connect to the optical edge. Then you can dynamically assign or allocate these certain wavelengths to a ring if needed, or you can dynamically take it back if no longer used. So this dramatically improve the wavelength resource usage, and then you can use less equipment, less wavelengths to support more customers. So this is from the metro access segment. Of course, for the access network, as we just discussed in the migration from copper to the fiber, actually, this also simplified the architecture. You can see, based on the copper now, VDS or copper, we use FTTC or FTTDP or even FTTD. So you still need a copper, and so this is a two-segment architecture. So if you go to full fiber FTTH, then you only one segment. So this also dramatically simplified the network architecture and also brings energy efficiency improvement. So I hope this answers your question, Martin.
Yeah, no, that's excellent, and obviously there's a lot of detail that people can go into as well. And we've got more detail in the white paper. I will move us on though to the whole, because I think it's a good segue into the whole topic of energy efficiency within facilities. And Mohammed, you listed a whole load, range of different approaches and challenges of energy efficiency within facilities. And I also see some questions coming in online about whatever you do, you probably need to adopt new cooling solutions within facilities in order to manage the extra operations of those facilities. So, Mohammed, could you say a few words about where people should start in telecom room efficiency, energy efficiency, and what's really the low-hanging fruit that you would recommend people start looking at in terms of optimizing efficiency within facilities?
Yes, thank you, Martin. I think what we have introduced is really the evolution, right? And indeed, there are trends impacting the telecom rooms, and there are suggestions in terms of the best practices according to whether the deployment is in the access, in the aggregation, in the call. There are best practices in terms of looking to putting in place the outdoors cabinets, which replaces room solution, and these types of deployment really reduce the energy consumption with an integrated ICT power supply. So these are measures maybe can be envisioned. But from broader perspective, I think what I can share with colleagues is that we look to from a holistic perspective, and I think Elspeth has mentioned something related to holistic approach, is that we look to from an entire policy aspect for the organization when it comes to energy management, right? And everything will be underneath when it comes to the rooms, the network consumptions, and all aspect of the network when it comes to energy. So we reference, for example, ISO 50001, which is the energy management system, in which we have considered this really a guiding standard for any company who would look into manage energy, right? Energy consumption, starting from putting in place a company policy, right? And the policy is the engagement of the top management, the budget allocated, and all the areas that are related with the energy management, including the telecom rooms, the networks, the data centers, and where every pieces of the network where energy is higher, right? So we can identify the where energy consumption, and then we can put in place a strategy and etc. down to the areas where we can bring innovative approaches, like as I mentioned for telecom rooms, outdoor cabinets. We are seeing this approach in terms of in access and aggregation, along with ICT converged power supplies, which really bring some efficiencies.
And it's interesting as well. You mentioned senior management buy-in and focus on this as being extremely important, just like you did on the copper to fiber transition as well. And I'd fully echo that without the commitment, because none of these necessarily give you an immediate return, and you need to stick with these to gain the benefit. So and that requires full buy-in from the organization. Philip, could I move to you for a second here and talk a bit about CPE energy efficiency? You picked up on that whole topic of Wi-Fi 6, Wi-Fi 7, and the energy efficiencies either in active mode and in idle mode. And you talked about better coding efficiency, better spectral efficiency. What do you see as the I suppose the time frame for the migration of the industry from Wi-Fi 6 to Wi-Fi 7? How quickly will it happen? What are the barriers? Obviously cost, perhaps, but what are the barriers for a migration from 6 to 7?
I think we'll see still Wi-Fi 6 for quite a while. Also, just based on the speeds, you can increase your Wi-Fi speed, but of course, if your broadband subscription is not in the same order of magnitude, it doesn't really help to over-dimension your Wi-Fi. So, if you look nowadays at the access technology, so XGS-PON is up to 10 gigabits. So let's say you have a multi-gig uplink connection, then it means that basically with Wi-Fi 5 or up to 6, which brings you close to that 10. So if you have, let's say, if you can go up to 10 gigabits with your fixed connection, you can link it to a Wi-Fi 6. That brings you theoretically also up to that same speed. So I think for Wi-Fi 7 to really kick off, we need to go beyond XGS-PON, because the promise, let's say the full capability of Wi-Fi 7 is 4 times higher. So it can go up to 40 gigabits. So I think it will still take quite a while, especially for residential applications, to see those use cases that would require Wi-Fi 7 to fully take over from Wi-Fi 6.
Yeah, and certainly from a use case point of view and the emergence of the metaverse and all of the scenarios that we talk about, we're still, there's increasing demand on bandwidth, but it may take a while before the demand really hits, for anything beyond, somewhere around the 10 GPON. There was a question actually asked online here, somebody saying that in the CPE model, we talked about the power consumption difference between active and idle. And the question was, and maybe somebody knows the answer to this, I don't, is there a big power consumption gap between high load traffic and lower load traffic? And are we aware of any difference in energy consumption or power consumption in that scenario? I don't know if anybody knows the answer to that question. And if nobody is jumping to answer that question, maybe that's a question that we'll fire out within the WBBA and see if we could get you an answer from one of the experts across the WBBA and send it to you offline.
Martin, maybe I'll try to.
Yeah, please do. Please do.
I also want to compliment what Philip was mentioning. I think the power conservation in general, particularly in optical access, has been an interest for ITU-T for a while. And there is a publication, a supplement on G Series 45 on this particular aspect. And there are, I will try to, to bring to the table the multiple techniques, right, and which are, according to me, are irrespective of the speeds, or whether it's higher rate or lower rate. So I think as an example, there is the ONU, for example, power shedding, which you can drop off the ONU from sometimes, when you're reducing power from non-essential services, and so you can keep the ONU on to the minimum services. Another example is ONU dosing, which I think in this case and this scenario, the dosing ONUs, keeps the downstream channel, for example, open for operational, but ignores, for example, the upstream allocation. Another example is the ONU cyclic sleep, which means that both the transmitter and receiver at the ONU level are turns off, right? At preset period, right, with periodic wake-up times to check the link state. So there are multiple techniques. I can mention many of them, like the watchful sleep mode, ONU deep sleep. All of these, techniques are already on the phone level network, and they are, let's say, according to my reading and understanding, they are irrespective of the downstream data rate. So this is what I can say, and it's the G supplement 45 in ITU-T. It's a great document that for additional reference. Thank you, Martin.
Excellent. Let me move on to another topic of interest. Now, Elzbieta, maybe I can direct one question towards you. You vaguely mentioned it, and it's mentioned a little bit more in the document as well, the role of AI in energy efficiency. And I know that's a topic that you've also been looking at. Could you say a few words around how the implementation of AI within operators is going to start making an impact on energy efficiency in the future?
Certainly, thank you, Martin. So I think, especially within kind of this topic and topic of sustainability in general, we do see that AI can be a great facilitator in terms of making improvements, whether it's, as we said, in terms of kind of the network evolution and innovation, what kind of helping with AI being overlaid over some of the network solutions and really help with in particular helping monitor the kind of the traffic and development of things that are happening within the network. We also see kind of use of AI increasingly in terms of monitoring kind of traffic and being used in CPs for implementation of idle modes and sleep modes, and kind of monitoring the behaviors of consumers and how, and then kind of implementing kind of sleep modes, idle modes, and CPs. But we also kind of, throughout working on this toolkit, we did identify kind of the innovation within AI and how it can kind of help with sustainability strategies and in general for service providers. And it is actually the topic of our next white paper, where we look at kind of the use of AI in telco sustainability, and we identified a few areas where AI is already being used in terms of network planning, and identifying the areas where AI or where networks should be deployed, leading to a more sustainable fiber network deployment. We also look at kind of use of AI in network management and operations, which goes. Some of this has been mentioned in terms of using AI in terms of the network facilities as well, and kind of deploying it in making energy efficiency moves and deployments there. So that's going to be upcoming in the next few weeks. It's probably going to be a few months, but yes, that's something that we're working on at the moment as our next step.
Excellent. Thank you, Elspeth. And for those of you who are not members, who are listening here and who are not members of WBBA, please join us if you have views on any of those related topics. Our time is nearly at an end here, but I want to kind of finish off with a question for each of the panelists, particularly maybe I'll start with James and then Philip and then Mohammed, which is the importance of energy efficiency and this particular topic that we're talking about today, the importance of that as a focal point within your organization, and is there a rising importance to it, and increase focus on this particular topic? So James, maybe everybody could just spend a minute. We only have about 2 minutes left in our webinar, so very brief answer, James.
Okay, yeah, yes, this is a very important topic, and the importance is increasing inside Huawei. So Huawei also created a cooperative sustainable development committee to handle sustainability topics, which also publish annual report to show how what we did and what we plan for the next year. And so we also attend a lot of organizations actively and contribute. So this, throughout all Huawei product and solutions, energy efficiency is a very important design topic also. Yeah, thank you.
Excellent, thank you. And Philip, within Nokia?
Maybe I'm going to take the controversial standpoint that I would say that it hasn't changed how we look at energy efficiency. It's been always important. The main difference is that they're no longer looking in dollars or in watts per bit. They're looking now at CO2 emissions, and that means to me that energy efficient is as important as it was before, but there is more now. There is the packaging, the transport of the product, the materials you use, how it can be recycled, refurbished. I would say that has gained. But energy efficient has always been important.
Okay, very good. And Mohammed?
Yes, Martin, similarly to the colleagues, it's really important, even to us. I think, as I said earlier, there is great commitment from the leadership and top management to really set the tone from the top and on environment-related aspect. Particularly, the concrete aspect is to put in place organizational structure that deals with environment-related matters across the company, right? It oversees all the plans, the action plans that need to be developed, and the strategy, and of course we have a team on energy is doing great work, which we gradually introduce in solar, green power, like the solar panel, for example, to power some portions of the network. And of course, as I mentioned, even in the procurement phase, we thought that it is important because there are national laws that are being considered in the procurement to consider environment-related aspect in the procurement phase. And this is another discussion, of course. But all these efforts, concrete efforts, are testament of the efforts.
Excellent. And a very good point to finish on. I think that's all the time we have for our discussion. I think it was really interesting, and there's an obvious level of expertise in this topic that's been expressed by our panelists out there. I could maybe ask everybody listening to this to see if you can take a moment to fill out our webinar survey, which is down on the right-hand side of the presentation screen. That would be great. I'm going to bring this to an end. We greatly appreciate the time of all of our panelists, and thank you to everyone in the audience for spending your last hour on this topic. I will ask you, anybody who is not a member of the WBBA, to reach out to us. A very simple process to join the WBBA, and it is addressing a wide range of very interesting topics, including this topic of sustainability. So you would be very welcome to join the WBBA. And with that, I'll draw this to a close, and thank you all for your time. Thank you.
Thank you.